Good morning to all. This is Srikanth Reddy, lecture in Electronics and Communication Engineering Department, working at Government Polytechnic, Jogipet. Today we will discuss the topic subject name microwave communication and television. In this subject we discuss the topic introduction to satellite communication. The subject code is EC405. Objectives. On completion of this topic, you would be able to understand basics of satellite and satellite communication, need for satellite communication, classification of satellite communication, advantages of satellite communication, applications of satellite communication. Basics of satellites are what is satellite. Arthur C. Clarke first time he used satellite word in Wireless World magazine in 1945. In 1945 year, the Arthur C. Clarke scientist first time they used the letter or they used the word of satellite in its magazine Wireless World. After 20 years, that is 1965, the first satellite launched by USA. The satellite name is Early Bird, and India launched a satellite through the help of Soviet Union in 1975 by the satellite name is Aryabhatta. These are the artificial satellites. These satellites mainly divided into two types: natural satellites and artificial satellites. What is satellite? A satellite is a object. A satellite is a physical object that is launched in any orbit. That is launched in any orbit which revolves around some celestial body, which revolves around that other bodies. Here, for example, the Earth is revolves around the Sun. The Earth is it is in one orbit which rotates as revolves around the Sun. Some other planets also. These other planets like Jupiter, Earth, Mars, these satellites are revolves around the sun. In this way, the solar system, like sun is the center, Mercury, Venus, Earth, Mars, Jupiter, Saturn. These are all natural satellites which revolves the sun. If the moon, the moon is the satellite, is also natural satellite which revolves the Earth. In similar way, these are the natural satellites. Some of the planets are revolves. The stars are sun are here. These are all natural satellites. If any artificial body or physical body which placed on a orbit, and these artificial bodies revolves around the planets or moon or sun, anything. So these are all the artificial satellites. So here the diagram shows the natural satellites, and these are the natural satellites like solar system. Moon, the natural satellite of Earth. This is a satellite diagram which is launched around Earth or other planets. This is the artificial satellites. So these are satellites. Here, a satellite is a physical object that revolves around some celestial body. Example, our own solar system. The Earth and other planets are satellites which revolves around the sun. Similarly, the moon is a natural satellite of Earth. Here, artificial satellite can be launched into orbit for a variety of communication purpose. A balance between the inertia of the revolving satellite and the gravitational pull of the object body keeps the satellite in orbit. So these satellites are artificial or natural, which gravitational forces used to help to rotating or revolves around the sun or other planets or Earth. Why satellite communication is useful or need for satellite communication? If we two stations are Earth stations, two stations are Earth to communicate through a radio broadcast, but they are far away to use conventional means. The two stations can use a satellite as a relay station for their communication. One Earth station sends a transmission to the satellite. This satellite is called a uplink. The satellite transponder receives the signals, amplifies and down converted and send it down into the second Earth station. This is called downlink. So here, why we going for satellite communication? We communicating two stations on Earth for a long distance, for our long distance. So otherwise, we communicate one nation to other nation. We can use the send the information from one station, and this information, this frequency sent or transmitted to Earth to satellites. This frequency is called uplink frequency or uplink. the signals are the frequency from earth station to satellite. Then the satellite contains transponder piece which consists of transmitter and receivers. So which receiving the signals or frequency from earth station and amplify it and down converted to again reflected to again reflected or retransmitted to earth station to other point. So these frequencies, these signals are called downlink signals. So receiving the signals from the earth station and amplifying it are down converted and retransmitted to the earth station. So this is the communication of satellite. So here the satellites, we can communicate any 2 points and point to multi-point and multi-point to multi-point. So in this way the communication is possible. These satellites are help to easy or very long distance communication. Classification of satellites. Satellites are basically divided into 4 types based on the signal processing, based on the height, based on the purpose, based on the area of work. These are the 4 types of satellites. Based on the signal processing, these are active satellites and passive satellites. Based on the height, these satellites are classified into geosynchronous satellites or geostationary satellites, non-synchronous satellites. Based on the purpose of communication, these satellites are classified into communication satellites and observatory satellites. And based on the area of working, these satellites called domestic satellites and Intelsat, international telecommunication satellites. These are the classifications of satellites. Classification of satellites. Based on the purpose. Based on the purpose, the satellites are classified into 2 ways: communication satellites and observatory satellites. Here, communication satellites, this receives the signal from earth station and process it and then retransmit it down to earth. Communication communicates the voice, video and signal over the entire world. Here the communication satellite means which is receiving the signals from the earth station and the satellite is processing and then retransmit to the earth station. Here the communication data is voice or video or text, images, any signals from entire the world. In this way we communicate the communicates. So these are the communication satellite. Observatory satellites. These satellites are used for gathering the information about the inaccessible terrain, hidden minerals, weather forecast, occurrences, earthquakes, etc. Send this information to Earth station. Here, the observatory satellite means which is used to observe the moon or other planets are gathering the information from entire the water or inaccessible terrain or hidden minerals or weather forecasts or occurrence of earthquakes or any other planet information. This information is gathering the satellite and returns into the Earth station. This information is used to study for other planets or weather broadcasting for future when the earthquakes or tsunamis come. So these are used for observatory satellites. Based on the height, based on the height of satellites are classified into two types, that is geosynchronous satellites, non-synchronous satellites. Here, geosynchronous means that it synchronous the Earth and the period of revolution is 24 hours, and these are the at height of 36,000 kilometers. That means here the geosynchronous satellite means the satellite launched above 36,000 kilometers orbit. That orbit is called as geosynchronous orbit. In this orbit, we launched any satellite. The satellite rotation is or the satellite revolves around the Earth or the satellite rotation is 24 hours, and similarly the Earth rotates 24 hours. So the Earth and geosynchronous satellites are same or constant way or which shows always constant position to each other. Then these satellites are called geostationary satellites. Here the Earth revolves evolution and satellite revolution is same, that is 24 hours. This type of satellites are called geosynchronous satellites or geostationary satellites. Non-synchronous satellites. The satellites launch other than geostationary orbits are lower than geostationary orbits. They are not a geosynchronous, these are at lower heights. If the satellites were launched below 36,000 kilometers orbits, like 500 kilometers orbit or 19,000 kilometers orbit, depends on. So this type of satellites are non-synchronous satellites. This satellite's revolution is not as same as Earth revolution. So these are called non-synchronous or non-geostationary satellites. These non-geostationary satellites are divided into LEO and MEO, lower Earth orbits and medium Earth orbit satellites. Here, up to 500 kilometers, the satellites are called lower Earth orbiters. Up to 500 kilometers, any orbital we launch any satellites are called LEO, lower Earth orbits. The satellites above 90,000 kilometers orbits, then the satellites are called MEO satellites, medium Earth orbit satellites. These two are the non-synchronous satellites. Satellites classification based on the signal processing. Here, based on the signal processing, the satellites are classified into active satellites and passive satellites. Here, active satellites The signal is received, the signal is amplified by the satellite, and frequency is down converted and retransmitted. So here active satellites means the satellites which receive the signals from the earth station, and these signals are amplified or processing or reallocation or channel location and down conversion. So heavy processing is there in satellite and retransmit to the earth station. This type of activities doing a satellite is called active satellites, means which receive the signals and amplify and returns into the earth station. These are the active satellites, means which participate, which role is active. Passive satellites. The passive satellite is simply reflect the signals. That means the satellite receives the signals and returns to the earth stations. The satellite receives the signals from the earth station and again retransmitted to the earth station. Simply reflects the receive signal and reflect the signal. This type of satellites are passive satellites. Based on the area of work, the satellites are classified into two types: domestic satellites, domsat, and intel satellites, international telecommunication satellites. International telecommunication satellite, domestic satellite. Domestic satellites. It represents the domestic satellite system, a limited area used for domestic communication, loop replacement to microwave links. Here, the domestic satellite means which has a limited area, that means any country needs a separate satellites, or that's a limited area we use the satellites. If, for example, we use domestic flights, that means we can the flights are used within the country, so limited area. This type of flights are called domestic flights. In similar way, the satellites are launched for the purpose of one country or limited area. So these are domestic satellites. These are the good replacement to microwaves. That is point to point or near distance or limited area. Intelsat. These are international telecommunication satellites. Short name of international telecommunication satellites. These are used for global communication. Here, international telecommunication satellites are transmitting the communication which use the communication internationally. This is the present mobile communication are used telephone communication used enter the world. This type of communication is called international telecommunication satellite. This is this is used for enter the global or world communication. These are two types of satellites based on the area of working: domestic satellite, inter satellite. Advantages of satellite communication over the terrestrial radio communication. Here, the terrestrial radio communication means we usually communication by the cables or limited area terrestrial network, and the satellite communication is used as entered the world. So the difference is that the advantage of satellite communication over terrestrial radio communication. The satellite communication is very flexibility. It is more flexible than terrestrial radio communication. These satellite communication has long distance communication. That means we can communicate for thousands thousands of kilometers, but we can communicate. These are a high speed data which transmit the data, very high speed data, some gigabits or terabits per second data we can transmit per second. It provides coverage over the globe. Satellite communication provides communication entire the world or entire the globe. So it is overall communication. Here, if the satellite launched in a geosynchronous orbit, then the satellites, that means three satellites are covered entire the globe. So the surface is covered over the globe or earth. So it covers entire the world or global coverage area. And the satellite communications are high capacity and high reliability. The cost of cable circuits increases with their length, where the cost of satellite circuits is independent of the distance between the earth stations. That means if we use from terrestrial communication, the cables are in the circuit. So the distance is increases, the cable size is increases. So then the same sizes are increases, the cost is increases. So when length of the cables increases, the cost is increases and the distance also increases. Then, but the satellite communication is not a depends upon the distance. So entire the cost is high, but it does not depends upon the distance. So here the distance is independent on communication satellite. Satellite can provide service to mobile stations. Presently, we use international telecommunication purpose or national telecommunication purpose used as satellite communication. So, these are provides international telecommunication or mobile station communication. Satellite transmission is not restricted by geographical conditions. In geographical areas like terrain, forest areas, or mountain areas, or sea areas, the terrestrial communication or the cables are not established or not installed. In this, uh, in this situation, the satellite communication is very useful. So it is not restricted by the geographical conditions. In addition, the communication software can be used for the other services also, like education, data collection, searches, and rescue work. These softwares for communication is used to help the education purpose and data collection from other planets, sun, or other mm, places in the earth. So these are used for some data collection purpose. We use satellite communication as searching purpose and rescue work. It can be used. The satellite communication is point to multi-point communication, where the terrestrial is point to point communication. Here the terrestrial communication or cable communication encrypts one point to another point, but in satellite communication it is point to multi-point communication and multi-point to multi-point communication. So you can transmit the signal as one point to another points. So the satellites receive the signal from one point and it can be transmitted to more places or and another places in the earth. The satellites receiving the signals from earth to earth in many places and we can receive more points or multi-point can be received and we can transfer to 1 point or the satellite receive multi-point to the information and it can transmit to multi-points also. So the satellite is used for point to point, point to multi-point, or multi-point to multi-point, or multi-point to point. In this way, the satellite communication is used. The mobile communication is easily achieved by the satellite communication. So here, mobile communication or international telecommunication, it is very easy to use or achieved by the satellite communication. Transmission cost of satellite is independent of the distance from the center of the coverage area. So here the satellite, whenever the satellite is launched, it very cost, but it's not depend upon the distance. Here the cables are the microlinks arrangement, the cost is increases by the length or distance is increases. The bandwidth of the satellite is very high. In satellite communication, we use large bandwidth data is used. Some gigahertz, terahertz data you can transmit. The satellites are provide quality of signals and this satellite communication has high quality signals are used. The cost of satellite is independent of distance. These are the advantages of satellite communication over terrestrial radio communications. Applications of satellites. The applications of satellites are TV broadcasting like satellite TV, digital TV, etc. So here the applications of TV broadcasting purpose presently used in mostly satellite TVs or dish TV or dish TV or digital TVs. These are by using the satellite applications. Global positioning system. The satellites are used to find the position of the target or position of the person by using longitude and latitude methods. So in GPS, in global positioning system, we use at tracking the any person, at tracking the vehicles, at tracking searching purpose. These satellites are used. Global positioning system and navigation purpose. In seas or in oceans, the navigation purpose, these satellites are used. And military, the satellite communication used for military communication and radio and TV program distributions. The satellite communication used as radio programs, international radio programs, or TV programs distribution, like streaming from one country to other country, used as satellite communication. Remote sensing applications such as study changes in Earth's surface, like ozone and greenhouse gases in the atmosphere, are mapping, mining, etc. The satellites used for remote sensing applications. So, some of the satellites are specially launched for remote sensing purpose. That means these are used observatory purpose. That means gathering the information from ozone or greenhouse effect or atmosphere information and mapping of the earth or mining where the mining occurs. So this type of satellites are called remote sensing applications we used in these satellites. Weather forecast application record weather and climate pattern around the world. The software used for weather forecasting purpose in such way in finding the weather forecasting or recording of weather or when the tsunamis or earthquakes occurs before the its come. So in this entire world, the weather information we can observe by the satellites, email, or internet. Well, the satellites are transmitted used or transmit the information signals from easily from one place to another place by sending the internet or email purpose. So worldwide we can communicate or transfer the information very quickly or easily by using satellite communication. Satellite can also monitor the status of Earth's surface such as land or oceans. So the satellites are used to monitor the status of Earth and surface of the Earth, like it also used to find the land or ocean range or ocean distance, ocean width and forest range. So satellites used to help for finding the area of land or oceans or forest. So this is monitor is also monitor the status of Earth's surface. They can observe crops, forests, lakes, and rivers. These satellites are used to help for crops position, how much how uh, how much area the crop area or how much of forest, how much distance, how much length of lakes and rivers. So this information is observed by the satellites to help. So these are the applications of satellites. General structure of a satellite system. Here, taken as head as the basic point, we have two stations or two points in head station A, head station B. In this way, these two stations are used for communication purpose by using satellite. So, if we use as satellite communication or geosynchronous communication, the satellite is launched 36,000 kilometers orbit. So the above the Earth of 30,000 kilometers used the orbital is called as geostationary orbit. In this orbit, if the satellite is launched, then the satellites are taking signals from the Earth station and the Earth station sends the information from Earth to satellite. And these signals are called uplink or uplink frequencies. That is, the signals are the frequency transmitted from Earth station to satellite, and the satellite is receiving the signal from Earth station point A, and the signals are amplified or processed and retransmitted to the Earth station at point B. So the signals coming from satellite to Earth station and B is called as downlink signals or downlink frequency. So the frequency transmitted from satellite to Earth station. So in this way, the communication is satellite is possible at the simply satellite structure. Station point A, it transmits the signals and the satellite is receiving the signals from the Earth station. That is processes, the satellite is processed and the satellite is retransmitted to the another point in Earth station B. So the here the satellite is retransmitted to point B. Here the signals are transmitted point Earth station point A to satellite is called uplink frequency. The satellite retransmitted from satellite to consists of earth station transmitter, satellite, earth station receiver. So here we have three ports. One is earth station transmitter. Earth station transmitter is called A, and satellite and earth station receiver called B. The users are connected to the earth station through terrestrial network. Here in earth station, we can mainly communicate by the terrestrial network, and the terrestrial network may be telephone exchange or dedicated link to earth station. So here the information is given to the terrestrial network to the earth station and dedicated link to the earth station, a telephone exchange to earth station. These signals are generated by the users or processed and transferred from earth station to satellite. So here the telephone exchange and dedicated link in the earth station is generating the signals from and processing to be transmitted from earth station to satellite. This station transmits the RF monitor signal up to frequency. So this station is transmit the signal from earth to satellite. This is called uplink frequency. This uplink frequency for C-band 6 GHz range. For Ku band, we have 14 GHz frequency. So the here the frequency used has some GHz range depending on band we use. The C-band uplink frequency is 6 GHz and Ku band for uplink frequency is 14 GHz. Then satellites receive the modulated RF signal from all the earth stations in the networks. So the satellite is receiving the signals from modulated RF signals from the earth stations on 1 or more points in the net from the earth stations in the network. And these received signals are amplified by the satellite. The received signals are amplified by the satellite. And the satellite is down converts the RF signal to earth station. These signals are called downlink frequencies. And this satellite is retransmitted the downlink frequency to earth station receiver. So here the satellite is retransmitted to the earth station. Here downlink means the satellite signals transmit to satellite to earth station. So here the signal frequency for C-band is 4 GHz and Ku band is 12 GHz. So in similar way, different bands we have different frequency range allocators. The received signal is processed and received the station get back to the original message. So the received signals are received by the receiving end of earth station, and these signals are back to the original message signal or requested the original message signal by earth station. This signal is then sent to the user through terrestrial network. So these earth station signals again transmitted through terrestrial network to user. Any cell. So in this way, the communication is done by the satellites. Here, the uplink frequency is 6 GHz for C-band and downlink frequency is 4 GHz. If used as Ku band, 14 GHz for uplink frequency and 12 GHz for downlink frequency. That means 3:2 ratio of uplink and downlink frequencies are exist in satellite communication. Basics of communication system. Theoretically, three geostationary satellites provide 100% Earth coverage. That means if the satellites are launched in geostationary orbit, this 36,000 kilometers orbit, then the in this orbit we use three satellites for cover entire the world or global area. All the geostationary orbits, the satellite covers 42.2% of the Earth's surface. So, in this question, one satellite covers approximately 42% of the Earth's surface. So, here three satellites are enough to cover the entire globe. Summary. In this class, we discussed basics of satellites, satellite communication fundamentals, classifications of satellites, advantages of satellites, and applications of satellites, satellite structure. Thank you. Thank you to all.